The finished baffles fall into a conveyor and go into a storage cage. Now, a long steel tube tumbles to automated blades which score the tube crosswise to prevent denting, and then cut it to produce smaller tubes that go inside a muffler. A circular saw descends on another tube to make a tailpipe. Its length depends on the type of muffler being made. A louver machine spins and punctures one of the inside tubes. The holes will regulate airflow in the muffler. A CNC bending machine grips and bends a pipe in several spots. This is how they make inlet, intermediate, and outlet tubes. These tubes run the length of the exhaust system. Then they place a tube in a circular hydraulic vise, which pinches the end down to a prescribed diameter to allow for further assembly. A worker now places two baffles in a jig. He fits the tubes through the holes in the baffles so that the tubes connect the baffles. 3 mandrels slide into the tubes. The mandrels expand, locking the tubes to the baffles. Then they contract and slide out. Now the baffles and tubes are one piece. Next, a robotic arm picks up metal sheets which will become the outer skin of the muffler box. It pushes them under an oval mold. Another arm with numerous rollers on it moves up and wraps the steel around the oval form. Then a metal block moves over the ends, double folding them. This locks them together, and it completes the assembly of the muffler's outside skin. Magnets pick up the new skin, and sliding on rails, they relay it to a mechanical claw, which in turn feeds it to a flanger. The flanger bends the edges, creating a lip on either end of the muffler skin. A carousel turns, and a mechanical claw transfers the newly flanged muffler skin to the stuffing position. Hydraulic pushers press the pre-assembled baffles and tubes inside the skin. After the muffler is stuffed, the robotic claw transfers it to a conveyor belt. Next, a worker presses each end of the muffler against a set of steel expansion fingers. The fingers move forward into holes in the muffler. They expand and lock the baffles and tubes inside to form one solid internal unit. Grippers place the muffler on a spinning machine that will fasten the caps on. Rollers press against the flared edges of the revolving muffler, tightly locking the end cap to the rest of the body. Here you see the rolling in slow motion. It takes only a few revolutions to do the job. Then the roller backs away, and a mechanical arm grabs the muffler and transfers it to a conveyor belt. Now these mufflers are ready to help keep the traffic noise at a minimum. If you have any comments about the show, or if you'd like to suggest today on How It's Made, individual transporters, cedar canoes, and electric guitars. It's the world's first self-balancing electrically powered personal transportation device. Built-in sensors and an onboard computer keep this $6,000 vehicle upright as it zooms around up to 3 times faster than walking speed. Perfect for large warehouses, delivery routes, or anyone who just wants a lift. Tough, lightweight construction materials enable the transporter to safely take you almost anywhere you'd otherwise walk or run. This aluminum chassis will house the vehicle's electronics. It can withstand an impact force equivalent to the weight of 3 large cars. Using a press, a worker attaches couplings to 2 motors. These couplings will connect the motors to gearboxes later on. For safety reasons, many of the transporter's components are doubled. Normally, they'll share tasks equally, but any of the twin parts can do all the work if the other fails. It's what the industry calls redundancy. Using 3 screws on each side, she installs the motors into the chassis. The worker then installs 2 controller boards in the top side of the chassis. Microprocessors in these boards control the motors. Then she adds what's called the balance sensor assembly. This includes 5 gyroscopes and 2 components called fluid tilt sensors. These instruments gauge the vehicle's position relative to the ground. The controller boards check these instruments 100 times per second and adjust the vehicle by rolling the wheels forward or backward when the rider leans either way. Next come wire clusters called harnesses. They connect the vehicle's batteries to the control shaft. The chassis cover doubles as a floor plate for the rider to stand on. When you step on, your weight pushes 4 rubber buttons. These disrupt an optical beam on the controller board, telling the transporter it has a rider. The harnesses fit through holes in the cover, which attaches with 8 screws. Next, she connects the harnesses to a power converter in the base of the control shaft. The power converter uses household electricity to recharge the batteries. Inside the gearbox, 4 gears transfer power from the motor and turn the wheels. The gears' teeth are cut on an angle so they engage gradually and more smoothly. This keeps the vehicle's noise to a relatively low hum. The worker tightly secures the gearboxes to the chassis with a mallet. Then she opens a waterproof rubber seal and plugs in the machine's power cord. She tests the electrical system to ensure that it's grounded and that there's no short circuit. Next, she uses 5 screws to attach one of 2 plastic fenders. A tapered metal hub connects each wheel to its gearbox. The wheels are about the height of a small bicycle tire, but 3 times wider. A molded rubber and metal mat covers the floor plate and snaps into place on both fenders. After flipping the chassis, a worker connects 2 batteries to the controller boards. When you plug the batteries into a wall socket, they recharge in about 8 hours. The transporter runs as far as 23 miles on a single charge, depending on the terrain. This machine tests the rider detect buttons by applying pressure in a random pattern. The rider and cargo must weigh at least 99 pounds, but no more than 260 pounds. The machine also tests the wheels and motors. Next, a handlebar on the control shaft. To steer, you turn the hand grip left or right. The motor responds by spinning one wheel faster than the other. You can also spin the wheels in opposite directions to make the vehicle pivot. Ignition keys with computer chips in them restrict traveling speeds to either 5.5, 10, or 12.5 miles per hour. The keys also instruct the vehicle to make slow, medium, or sharp turns. Now the fun part, taking each transporter for a test drive. The tester listens for unusual sounds and checks for vibrations coming from the gearboxes. He feels how quickly and reliably the controls respond. He runs the transporter up small inclines. It's designed to conquer slopes of up to 20 degrees, depending on traction with the ground and the weight on board. It goes down over a sidewalk curve just as easily. Only after this thorough test drive is the transporter ready for its first real trip. Canoes are truly vessels of history dating back as far as 10,000 years. Native North Americans made them with frames of wooden ribs covered with bark. They used these boats to fish, travel, and trade. Today's canoes blend traditional construction with some high-tech materials for even greater durability. Most of this boat's made of white cedar, which is lightweight and weatherproof. But for reinforcement, the rim and leading edges are made of ash, a heavier wood. Construction starts with an upside-down template of the canoe that's 15.5 feet long. A worker clamps 2 long strips of ash, called gunwales, to create the canoe's inner rim. Then add similar strips curving along the 2 extremities. He'll attach the rest of the skeleton to this rim. Workers soften what will be the boat's inner ribs in nearly boiling water for 45 minutes. The ribs are 2 inches wide and almost a ½ inch thick. The hot water makes them relatively pliable. Using a hammer for leverage, they simply bend the ribs over the template. Steel guiding strips ensure the ribs are 1 3/4 inch apart. With a pneumatic staple gun, workers fire 2 stainless steel staples through each end of the ribs and into the gunwales. Cement blocks weigh down some of the 43 ribs that workers secure over the entire canoe. At this point, the ribs measure between 3 and 5 feet long.